So I've talked about how the brain activity in a well-learned movement in the later stages of motor learning actually shifts back into the cerebellum compared to the decision-making part of the brain, which is the prefrontal cortex. So I want to talk about the process of what's actually happening in those stages. So in the early stages of motor learning, we're going to use a lot of the prefrontal cortex and the motor cortex, so the decision-making part and the motor cortex, to come up with that movement and consciously having to think about that movement. It's going to be a little bit of a slower process. All right, but once we start to learn that movement, that's when I talk about how it starts to shift back into the cerebellum. So what's actually happening in the cerebellum is the cerebellum is creating a working model of the motor cortex that allows it to use those same properties to come up with the motor plan. But what's interesting is that it's also taking in all that sensory input that I keep talking about. So it's creating this working model of the motor cortex, which is in the cerebral cortex, and it's taking in all this sensory input from the rest of the body. And that's what allows us to establish that movement at a such faster rate than using those prefrontal and motor cortex. And this allows those parts of the brain to start working on different parts of new movements, or if we're playing a sport, like tactical situations. So the cerebellum, having those learned movements in our cerebellum, allows these decision-making processes to start working on different situations that allow us to amplify our game or amplify our movement to even a different level. So that's why it's so important that the cerebellum creates this working model of the motor cortex and takes in this sensory input, and it creates this movement at a such faster rate than it would be in those early stages of motor learning.